Hey everyone, it's Mr. Lambert with your small group video for the first week here of Cycle 3B. If you were unable to make it to your group this week, I know for some of you, I think you may have had trouble getting on the Zoom call while I was Zooming from home. So what I'm going to do this week, if you go ahead and watch this video and then respond to the question at the end of the video, I'll give you full points for attending group for this week. Please make sure that while you're watching the video, you have a piece of paper and pencil and you are working along with me while we're talking through the different problems here. Be ready to pause when I ask you to. All right, so last week we finished up our skill 6.af.1, which was our first look at variable expressions. This week, we're moving on into 6.af.2, which is using common properties of math, like distributive, commutative, and associative properties. Those are our three biggies. We're going to use those in order to create equivalent linear expressions. That's going to be kind of our next skill, so we need to get this part down. And balance algebraic equations, and that we'll start doing next week. So we've got to get these properties under our belt first. So today, what we're going to do is we're going to look and make sure we feel comfortable with PEMDAS, or order of operations. Then we're going to make sure we're comfortable creating those variable expressions. We're going to review the properties we'll work on in this unit, and then practice with the associative, commutative, and distributive properties. And then last but not least, if you want to watch at the end, it's kind of the bonus section, looking at creating equivalent expressions. So first things first, I would suggest you got a piece of paper out and go ahead and see if you can, go ahead and pause this video, see if you can figure out the answers to these two questions. I'll work them with you here in just a second. Okay, so hopefully you pause, because otherwise watching this video is kind of useless. But hopefully you care enough about what you're doing in class to try along with me. So we've got 36 minus 8 times 2. We're going to go through PEMDAS. So remember, in PEMDAS, P means parentheses. E means exponents. I'll put a little exponent 2 there. M and D are for multiply and divide. And we move left to right. Last but not least, we add or subtract. That's the A and the S. And then again, we are going to move left to right on these guys as well. So no parentheses here and no exponents, but we do have, so the first two are done. We do have multiply or divide then, and we have a multiplication part right here. So I'm going to rewrite until I get to that multiplication part of the problem, and then I'm going to do that. So 8 times 2 would be 16. And then last but not least, we just have one subtraction thing left, and that's our last bit to do here. So 36 minus 16 would be 20. There you go. This was probably the one that most everybody got right during our groups. Now this one was a little bit harder. In the first two steps we did okay on. So of course, if we're doing PEMDAS here, parentheses is going to be first. We've got 5 plus 4, and we can make that 9. We're going to take that and rewrite it with the square minus 3 times 7. Now, a lot of people do a lot of different things next, but the next thing we need to do is our exponent. That's the E. We'll take 9 and multiply it by itself. Remember, this is not just 9 times 2, because that would give us 18. This should actually be 9 times 9. We're taking the base and using it as a factor 2 times. So 9 times 9 would give us 81 minus 3 times 7. Now here's where most people made the mistake. At most groups, people trying to subtract the 3 from 81 first and then multiply by 7. But remember, we're going to multiply or divide first before we add and subtract. So we'll do this multiplication portion of the problem first. So we have 81 minus whatever 3 times 7 is, which is 21. And now we just have that subtraction portion left. So 81 minus 21 would give us 60. And there we go. That's the answer. So remember, as you're doing this, watching through and doing those steps in order as they go through. We're going to throw some of that out of the window here in just a second, but there are very special situations where we can do that. We'll talk about that here when we get to our properties. All right. For now, just remember that PEMDAS. It'll always work in that order. Sometimes it just may be easier to work in a slightly different fashion. All right, so here we go. I've actually put in some highlights here. This is what I did with the class, but we're going to create a variable expression here. So Lenore is putting together Valentine's Day bags for her class. She can't remember how many students are in her class, but she knows that she wants to give each student 3 stickers, 2 Jolly Ranchers, 4 Tootsie Rolls, and a Valentine's Day card. Help her to create an expression to show how many items she'll need in all to complete her bags. So the first thing you need to do here, and this one's already done for you, we don't know. What we don't know is how many students are in her class. So she can't remember how many students are in her class. And we're going to need that to know how many things she needs, because we're going to take each of these bags worth of stuff, but we need to multiply them by however many kids are in the class. So we're going to take S and let that equal the number of students in Lenora's class. That way we can take S and multiply it by the number of things in each bag. So we have 3 stickers, 2 Jolly Ranchers, 4 Tootsie Rolls, and 1 or a Valentine's Day card. And if you add those up, you get 10 and multiply it by that S. 10S would be the simplified version of your answer, but this would most likely be what you would have for your expression. Remember, the things you need in order to create an expression, you've got to have a variable. It has to be identified. And then you have to give me, it's got to have numbers, operators. That makes it an expression. So this is what you should be looking for here as you work through a problem like that. All right, moving on into the new stuff. Sorry. There we go. So we've got 4 times 3 plus 4 times 6 plus quantity 4 times 2 equals. And we were talking about mathematical properties. So what I wanted this to get to, and I don't think any of my groups quite got to this point, but I asked them to rewrite it in a different way. So what you could do, this is basically the distributive property backwards. This is what the distributive property looks like after we've used it. So you could rewrite this as 4 times the quantity 3 plus 6 plus 2. Basically, what the distributive property says is you can distribute that thing throughout and multiply it by each of those things, or you can take whatever the common thing is, take that out, and then put it outside the parentheses. Now, it's not super helpful as we're working through with actual numbers, but whenever we get to working with variables, this can be super, super helpful in helping us to what we call isolated variables. So we want to get the variable by itself, and then we're going to use what's called inverse operations, which we'll talk about next week and actually at the end of this video, to get the variable by itself on one side of the equation. So this can be very helpful when doing that. But remember, the distributive property just says if I'm using anything on the outside of a set of parentheses, I can distribute it. There's where the word distributive comes from. I can distribute it throughout and use that as a different form of the same equation. Now, it doesn't help again with numbers, but if I had variables in here, like an x, a y, and a z, I could break this x, y, z times 4. I could break it into this if it was more helpful for me to work through a problem that way. Or I could take the 4, pull it out. Whatever is the most helpful as we're working through the problem. All right, the next section was true or false, and we had a couple of true or false problems. So the question was, I've got 3 plus the quantity 6 plus 2. Is that equal to 3 plus 6, the quantity 3 plus 6, sorry, plus 2? Well, what do you think? As we're working through this, you can do the math. So 6 plus 2 will give you 8, plus 3 will give you 11. And then we'd have, over here, we'd have 3 plus 6, which gives us 9, plus 2, but that also gives us 11. So these would actually be equal. But without doing the math, I know that these are equal because this is a property called the associative property. The associative property says that if I am dealing with just addition or just multiplication, and it only deals with those two sets of operators. So if it's just addition or just multiplication, I can actually move a set of parentheses anywhere I want in a problem in order to help me solve it easier. Now, again, this doesn't help so much when we're just dealing with numbers, but if I had something like this, let's say I had 3s plus the quantity 6s plus 2. Well, I can't add my s's up because this is in a set of parentheses with my 2. But if I change that set of parentheses, now I can take this and I can add my s terms together. So 3 plus 6 is 9. And because of that distributive property, I know that I can add those together even though they're being multiplied by s. So I'd have 9s plus 2. That actually makes this property super helpful when I'm dealing with multiplication or addition. Now remember, it's only those two operations, and even if I start to mix multiplication and addition, the property doesn't work anymore. It only works for one operator in an equation. But these two would then be equivalent. We call them equations. Sometimes, again, we'll make this easier to work with. So my next question, is this a true equation? Are these two expressions equivalent? So I have 8 minus the quantity 6 minus 2, or the quantity 8 minus 6 minus 2. Again, this looks just like what we had last time, right? Well, not exactly, because instead of using, remember, the associative property only works with multiplication and addition. Here we're using subtraction, and watch what happens. I have 8 minus the quantity 6 minus 2, so that would be 8 minus 4, and this would be 8 minus 6, which would be 2 minus the 2. On this side, we have 8 minus 4, which is 4. This side, we have 2 minus 2, which is 0. Now check that out. These are actually not equivalent. This would not be true. This would be false. And that, again, is because if we use anything other than addition or multiplication with the associative property, it breaks down. It doesn't work. Or if you mix operations together. So remember, if you see it, if it's just addition or just multiplication and you're changing where those parentheses are, that does work. That's the associative property. Here's our next property. This we call the commutative property. I actually have it written on the slide there, so I'll let you in. Yes, this is actually a true expression. Now, this may not look like it is true to some of you because the number is in a completely different order. We've got 8 times 2 times 4, or 4 times 8 times 2. But when we work these out, 8 times 2 is 16, times 4 is 64. And then 4 times 8 is 32, times 2 also equals 64. The commutative property says if you are dealing, again, only with multiplication or only with addition, it doesn't work if you start breaking these up. But if you're just dealing with one of those two operations, you can actually move the numbers in any old order you want to. It doesn't matter which ones you multiply or add first. But again, this only works if it's all addition or all multiplication. If you start mixing operations or you're using subtraction or division, this breaks down. It doesn't work. Remember, commute means to move. Like if you have a parent that works in Indy, they would call the drive there and back when they're moving, they would call that their daily commute. Commutative means we're going to move the numbers around. But again, this breaks down unless you are dealing with just multiplication or just addition. Again, not so helpful with numbers, although I use it a lot when I'm doing simple multiplication because I like to pick and choose what numbers I want to multiply together first. Like in this case over here, I would probably do this one first because for some reason I know that 16 times 4 is 64. Even though this side's not hard, I can pick and choose which numbers I want to pull out first. All right, so that again is the commutative property. Moving on. Simplify the following expression. So here's where we're getting into the stuff we're actually going to be working on a little bit next week. Simplifying an expression or giving me what we call an equivalent expression. So we can do this a number of different ways. Now this is cool because we can use the distributive property here, or we can go ahead and work with PEMDAS. The only thing you have to remember when you're dealing, at least when we come to this, when we're dealing with variables, is that if you have variables next to a number like they're multiplied with, you have to find, you can only add, subtract, multiply, divide other variables with a number by them. So like if I had like 3x plus 8, I can't do anything with that. That's as simple as I can get it. But because in here I have a 3x and a 4x, these are what we call like terms. They're both multiplied by x. So I can actually add, subtract, multiply, divide these guys, and it doesn't do anything. I can treat them like regular numbers, just putting the term x at the end. And this actually happens because of those properties we talked about. So in this case, you could do one of two things. You could either multiply 8 throughout, so you could have 24x, because 8 times 3 is 24, plus 8 times 4 is 32, 32x, and you could just add these up now. 4 plus 2 is 6, and 3 plus 2 is 5. You get 56x. Okay, 56 times whatever x is. And we don't know what x is, so that's as simple as I can get this expression. Also, we can do it the other way. We can do it regular old PEMDAS. So we could say 8 times 3x plus 4x. 3 plus 4 is 7, so we could say 7x. And then 8 times 7, well, that's easy, 56, right? We still have the x there, though. You can see we come to the same answer. So the nice thing about these properties is you can use them or you can use PEMDAS. Either way you want these to work, you can run through those equations, whatever is the easiest for you as your mind tries to wrap around getting that variable by itself. In this case, we did. We got x by itself, and that's as far as we can go. 56x, we can't really solve for it because we don't know what that x stands for yet. Let's erase that. Move on to our last question. Okay, so I've actually got this solved out for you, but I want to talk through it with you. So this is actual algebra, and this is actually what we'll start working on next week. We're actually going to what we call solve for the variable. We're going to find a solution to this equation. The whole trick with algebra is to get the variable by itself. So like we did with the last question, we'll either get it to the simplest form of the equation we can, or in this case, we're actually going to, since we only have one variable, we can actually get that variable by itself on one side of the equation, and that will tell us what it equals. Watch how this works out. So in this case, because I have one variable and then a regular number inside of this parentheses, I'm going to use the distributive factor to simplify this part out. So I do 6 times 4, which is 24, and that's still times x. So 24x minus 4 times 14, which actually gives me 56. So I've got 24x minus 56 now equals 40. Now, I'm going to use what's called an inverse operation. Right here, I've got a negative 56, right? But what's the opposite of minus? Well, that would be to add, right? Opposite of subtracting is addition. So if I add 56 to both numbers, and remember, if I do something to both sides of an equation, the equation is still going to work out to equal. If I have 0 equals 0, which is a true statement, and I add 1 to both sides, well, now I have 1 equals 1, and that's still a true expression. 0 times 1 on both sides would still give me 0. It's still a true equation. So I can work with these things, and I can change what the equation looks like by just doing the same thing to both sides. And remember, if you do an inverse or an opposite of something, generally it will negate or take away the thing on one side of the equation. So in this case, I'm going to add 56 to both sides. So 56 minus 56 is 0. That 56 goes away. Now I just have the 24 on this side of the equation. And then I have 56 plus 40. Well, that gives me 96 on the other side of the equation. So now I have 24x plus, or 24 times x equals 96. And again, this is times, so what's the opposite of multiplication? Well, that would be division. So if I take 24 over 24, or 24 divided by 24, that gives me 1. And 1 times x is just x. That's that identity property that we've looked at this week. So now I've got x by itself, but remember, I have to do the same thing to this side of the equation. So if I take 96 and divide it by 24 as well, I get 4. So I have now that x equals 4. Now, I've done all that work, but I probably should check it. So let's plug our numbers in. So I have 4 times the quantity, 6 times 4 minus 14, and that should equal 40, but we're going to check it out. So I've got 4 times 6 times 4, so let's just say I want to do it this way. 4 times 24 minus 14 equals 40. And again, I can do this either way. I can distribute or I can use PEMDAS. I'm going to use PEMDAS in this case because I know 24 minus 14 is 10, and that's an easy number for me to work with. 4 times 10 equals 40. Is that true? Well, yeah, 4 times 10 is 40, and 40 does equal 40. So not only did I solve for my variable, I actually plugged the variable in, checked it out, and it works out okay. So I know I was correct in solving that expression. Well, that's actually what we're going to be working on next week. Hopefully you found that kind of cool. That is the for real algebra that we're going to start on as we go into next week. It's actually my favorite part of math. It's like a little logic puzzle every day. All right, there you have it. That was our group for this week. So what I would like you to do, you should see a link below, but the directions for you today are, if you would like credit for what you just watched, you need to do the following. I need you to write me a short 1 paragraph about what we covered in today's walkthrough. So I would suggest maybe you go back to the beginning of the video, maybe like somewhere around right here. You can say, hey, today we talked about PEMDAS, we talked about creating variable expressions, we reviewed the properties that we've been working on this week. We practiced with the associative, commutative, and distributive properties, and we looked at creating equivalent expressions. And then once you've told me that, I would like you to tell me one thing that was new to you while you watched the video today. And don't tell me nothing, because I know for each of you, I haven't had anybody in any of my groups, even my kids who have the highest scores in math, they all have this was all working on something new as they went through this week. So tell me what was new to you. Tell me what we covered. It should give you a good 1 paragraph essay. Send that to me via email, and I'll give you full credit for your groups for this week. All right, guys, thanks. We'll talk to you soon.